So this video is going to be about how to design a supplementary kiln controller for a kiln that just has a kiln sitter. So the backstory on this is that I bought a older kiln and all it had was a kiln sitter. I had to replace the sitter tube, the thing that holds, that sits on top of the cone. I had a bunch of spare parts laying around that were like temperature related. Like I have a temperature controller and a couple of relays, and I decided that I was going to be able to put together something kind of similar to those digital controllers that you see on the new kilns. So we're going to go over how to design and build one of these. You might not have these parts, but it's a great learning experience either way. So the overview of this controller is essentially it works off of this Omron temperature controller. In here you can set 3 alarms, set point, and your process value, which is the current temperature. You can use a type K thermocouple that's hot enough for a kiln. So I think I'm going to buy the one that Scoot sells and just attach it to this controller. There's a couple of things in series in parallel with that. So I got a timer relay, simple timer relay. I'm going to be setting it to hours so that I can set it for 15 hours, 20 hours, whatever I need to hit my cone temperatures. I got a little power monitor on here for fun. I got an e-stop, and this is our test load before we wire it up into the kiln. So here's a quick overview of how it works. So right now it's already triggered. I can reset the relay by turning it off. Let's just set it to 3 seconds. Right now it's set to seconds because I don't want to sit here for 15 hours. Turn it on. Contactor clicks in. Turns off after the amount of times. That's one of the ways it can turn off. The other way it can turn off is if it hits the set point value that we set up in this controller. So the goal of this was to have a couple of different monitors other than the plyometric cone that we set for our firing temperature on the kiln sitter. This way, we have another form of temperature monitoring, and I have a rough idea of where we are in the process. And we also have a maximum time. Like we don't want it going for more than 24 hours. That's not typical. That would probably mean that one of the heaters is blown or something. So at least we'll just cancel the operation if that happens, and if you happen to be close by, at least you can turn it off quickly with the hit of a button. So it gives me a little bit more assurance, especially when you're dealing with an old kiln like I am, and we'll see how it works. So I turned the thing off, I got it open, and I think I'm going to do another part to this video showing how we're going to wire it in, because we still need to clean up some of the wires in here, and obviously this is the wrong temperature probe. This is just so that the controller doesn't bug out, and we need to do the high voltage wiring over here. So what we got is we're gonna pull a 120 line off of the kiln. That's gonna be this wire. That's gonna go into a couple of terminal blocks. Fun thing that I learned about these terminal blocks that I didn't know before, if you're new to control and automation type projects, is that when you want to do a shorting bar across multiple terminal blocks, you won't be able to put it in initially when you first buy them, because there's these little plastic tabs that you got to break off for all the ones that need to be shorted together. So once you break them off, you can push these shorting bars in, and now these are all connected together. So the plan is to have 120 volts come off of the input of the actual kiln controller. So there's some dials on my kiln for high, low, and medium for each of the top and bottom coils. So somewhere before that, we're going to take off a 120 leg, and it's going to pop into the ground, the neutral, and into a fuse. The fuse goes into the hot bar, neutral goes into the neutral, and that in parallel powers the power monitor. It goes to the switch for the relay. Before powering the relay, it goes into the temperature controller, and then the outputs of this relay contact and this alarm are in series with each other, and they are also in series with this e-stop. And if all of these are closed then the A1 and A2 contacts here on the coil for the contactor get power, and that's what lets the contactor turn on and says it's okay to have the kiln heaters on. So the only other thing we got is we're gonna put this current transformer over the wires of the kiln so that we get a rough idea of how much power we've used for each firing. And that'll just be interesting to know. If it stops working or something, we're just going to take it out because I don't really care for it that much, but we had it, so we put it in. So a quick schematic of how the control circuit works for anybody who's interested. It's just going to be the e-stop, normally closed, e-stop, normally closed. That goes to the timer relay. That goes to the temperature controller. And then that goes to the, that's kind of ugly. That goes to the coil of the contactor. And then that goes to neutral. So if all these are happy, then power can flow to the coil closes, and the kiln can turn on. Very simple, but it works. Here's one of these timer relays that we're going to be using. You can see this type of relay has one coil and two Form C contacts. So Form C means that it has a normally closed and normally open contact, so it has a common, and then you can either choose if you want it to be open when off or closed when off, and it has two of those. That's what Form C is called. And this is just going to be for control, so the power rating doesn't really matter that much. As long as you keep it under that, you should be fine. So it's not for switching large loads or anything like that. And the cool thing about these things is it's pretty nice user interface for a human to come and just set some time on it. They pop out. They're like octal base DIN rail mounted relays. So when you need to replace them, you actually just pop them out and put a new one in. There's like a key right there so that you get it in the right way every time. And the other cool thing is how you change the modes on them is, let's just pop this in here so it sits. So if you look up the data sheet, you'll see these different modes, A, B2, B, E, J, A. So you can go and change the modes, and the modes are anything from like interval, so like, you know, every 15 seconds turn on, after 15 seconds turn off, or you can have it be on for 15 seconds, then off forever, or off for 15 seconds, then on forever. So you can really like choose how you want this thing to behave pretty easily. And when you want to deal with the time units, you can go over here. I think this is the right one. And you can see that they will change their denominations as you spin it around. Isn't that cool? And then for this does seconds, hours, minutes. There's minutes, there's hours. And here is 10 hours. So our plan for this kiln is actually going to be in this setting. We're going to put it in 10 hours, and then we're going to put it in this mode. So we're going to have it around, that's going to be 10 hours, 15 hours, 20 hours, 25 hours, and we're probably going to put it somewhere around here at 18 hours. Where's 18 hours? Somewhere around here. So yeah, pretty nifty little device if you don't want to do too much programming. Oh, you can see that's the pinout for the actual block down there. Yeah. Neat. So let's just test out a few functions make sure everything's working okay. So we can set that to 4 seconds. Turns on, turns off, reset the relay, set it to 20 seconds, turn on, hit the e-stop. We're doing twist out. Turns off, turn off the relay, reset the e-stop. We got the temperature thing. Turn it up a bit, flip it on. But we have an issue there. I need to figure that one out. Okay, so we got it figured out. What was the problem was that the alarm type was wrong. I'm going to put a screenshot of that in the video. And essentially the alarm before was defined as an upper limit alarm, but it was also a mixture of a deviation value plus a hysteresis to stop it from triggering too quickly. So in this controller, at least, you have to hold down for 3 seconds. 1, 2, 3. You scroll over to alarm 1 or 2, for example, and you need to change this number was 2, and you need to make it 8. 8 is absolute value upper limit. So now as soon as it hits whatever value I set it to, it will trigger. So we should get one of the alarms to come off at any time. So let me just make this a little warmer. You can see alarm 1 went on right away. Alarm 3 is set to the same thing. So if I try to turn this on, nothing happens, which is great. And then, alarm 3 is definitely the one that's set up for this. So yeah, if it cools off, alarms turn off. Let me heat it back up. Then alarm 3 kicked in, and boom, turns off. So nice, it works perfectly now.